4.2, degrees and radians. Degrees and radians are different ways to measure angles of a triangle because we're focusing on a triangle. And so because they're different types of measurements, we need to be able to convert back and forth between them. So if we're given degrees and we want radians, we're going to multiply by pi over 180 degrees. If we have radians and we want degrees, we're going to multiply by the reciprocal, 180 degrees over pi. So here's an example. Convert 5 pi over 12 radians to degrees. So we take our original, which is 5 pi over 12 radians, and we multiply that by 180 degrees over pi. Now we don't actually need to show that radian, and then we just simplify. So we'll simplify the pi, and then multiply 5 times 180, that gives us 900. 12 times 1 gives us 12. So that ends up being 75 degrees. Now radians don't always have to have a pi in them. Remember, pi is 3.14. So you can also have radians as a decimal. If you were to take 5, multiply it by pi, and divide it by 12, then you could still have a measurement in radians and it would appear like a decimal. So for example, I could give you 2.3 radians and I want you to change it to degrees. So we do 2.3, you do the exact same multiplication, 180 degrees over pi. So you end up getting 414 degrees over pi, and then you put that into your calculator, and I'm going to round, it's approximately 131.78 degrees. Now what about if we go degrees to radians? So negative 40 degrees to radians. So we take that negative 40, we multiply it by pi over 180. So we end up getting negative 40 pi by multiplying numerator times numerator over, well, that's implied as a 1 times 180. And then we're just going to simplify. Negative 2 pi over 9. And then our units are radians. The other topic that we need to talk about today is this concept of coterminal angles. Coterminal angles are two angles that have the same initial and terminal sides, but yet they have different measurements. So let's first review what an initial and a terminal side is. You may remember from last year that initial sides start on the positive x-axis. So this is our starting position. So this is our initial side. A terminal side is wherever the angle stops. So let's say here. And I'm just going to identify this as rotating counterclockwise. and this is going to be 54 degrees. So this is an angle in standard position. Now, if we want to have two angles that have the same initial and terminal side but different measurements, my first angle would be 54 degrees. Now, if this terminal side actually rotated a full 360 degrees, it would appear as though the terminal side was in the exact same spot, but yet the measurement would be different. So to come up with a coterminal angle, I'm going to take 54 degrees, which is the initial, and I'm going to add a full rotation. When I add 360 degrees, I end up getting 414. Now imagine I took that original and I subtracted 360. So what that means is that I have my original terminal side, and instead of rotating counterclockwise and adding 360, I actually subtract 360, which is a full rotation, so my terminal side appears to be in the exact same spot, but yet it'll have a different measure. If I have 54 and I subtract 360, then I'm left with negative 306. So therefore, 54, 414, and negative 306 are all coterminal angles. So 360 degrees is one full rotation. That is 2 pi in radians. So if you were given a coterminal question and it said, and you were given the original angle in radians, you would add and subtract 2 pi because you need to be consistent with your units rather than adding and subtracting 360 degrees.